Students, welcome to my channel. In this video, I'll be explaining about the classification of solid that is based on molecular force of attraction between the particles. Okay. In the previous video, we studied about the classification of solid that is based on how the molecule is arranged in the solid, right? That is crystalline and amorphous. Okay. Here we will be studying the second type of classification that is based on the molecular force of attraction between the particle. Okay. If you haven't watched that video, please watch that video and come back to this video. Okay, now based on this type, we have four types of solid. Okay, one is the metallic solid, the second one is the ionic solid, third one is the covalent solid, fourth one is the molecular solid. Okay, these are the four types of the classification that is based on the molecular force of attraction between the particle. Okay, we will see the first one, that is the metallic solids. Okay, we all know that the metals have very low ionization energy, right? They have low ionization energy, right? What is ionization energy? Ionization energy means it is the amount of energy that is required to remove the outermost electron from the atom, right? It is the amount of energy required to remove outermost electron from an atom, from a gaseous atom. Okay, from a gaseous atom. Okay, now we know that metals have low ionization energy. That means if you consider this is the metal, okay, this is the metal nucleus, and imagine these are the shells, okay, and imagine this is the outermost shell containing the electron. Okay, it contains one electron at the outermost shell. Of course, we have electron in the inner shell also, but for simplicity, now I consider only the electron in the outermost shell. Okay, now this is the nucleus. Okay, we can see the nucleus, between the nucleus and this electron, there is a large gap, right? There is many shells between this electron and this nucleus. As a result, this electron experience a lesser force of attraction from the nucleus, okay? Because this electron is very far from the nucleus. As a result, this nucleus holds this electron less tightly. Okay, as a result, now I can remove this electron by applying little energy, right? That is what I meant here. They have low ionization energy. Okay, it is the amount of energy required to remove the electron, okay, outermost electron from the atom. Okay, since this electron is very far from the nucleus, this electron is loosely held. Okay, if it is loosely held from the nucleus, I can remove this electron by applying little energy, okay, little ionization enthalpy. Okay, now if I remove this electron, what happened to this atom? The atom get converted into ions, right? If the electron is removed, it become a cation, right? It become cation and electron is ejected. Okay, electron is ejected. Electron get ejected from the metal and that metal become cation. Okay, so in the metallic solid, you can see, okay, or it consists of the positive metal. Okay, cation means it is a positive ion. Okay, it consists of positive ion and C of electron. Okay, C of electron. Okay, metallic solid means it consists of positive ion and it consists of C of electron. Okay, I just represent the metallic solid like this. Okay, I am writing M plus because I am representing positive ion. Okay, and there are many M pluses, right, in the metal. Okay, and this electron will be present in the solid like this. Okay, they are not fixed to the position, they are randomly moving all over the solid. Okay, and because of this reason, the electron is randomly moving. No, because of that reason, this metallic solid is a good conductor of the good conductor of heat and electricity. Okay. Why metallic solids are good conductor of heat and electricity? Because this electron is randomly moving all over the solid. Okay, because of that reason, metallic solids are good conductor of heat and electricity. Okay, reason is randomly moving electrons. Okay, randomly moving free electrons. Okay, free electron because they are not fixed to any certain places. Okay, they are freely moving all over the solid. Okay. And they have high melting point and boiling point. Okay, they have high melting point and boiling point. Okay, they have high melting point and boiling point. And these metallic solids are highly ductile, and they are malleable. Okay, these are the properties of the metallic solid. Okay, malleable in nature. Okay, what are the examples? The examples like iron, nickel, copper, zinc, etc. All the metals comes under metallic solid. Okay, this is about metallic solid. The next is the ionic solid. Okay. Second, ionic solid. Okay, in this type of solid, we can have or we can see the ions. Okay, it consists of ions. Okay, ions. What are the ions? Cation and anion. Okay, I give an example for this ionic solid. Examples like NaCl, KCl. All these are the examples for the ionic solid. Okay, because this type of solid contains ions, cation and anion. Okay, what is a cation here? Na is the cation and Cl is the anion. Here, cation is K plus and Cl is the anion. Now, between this cation and anion, there will be an interaction, right? That force of attraction that holds this cation and anion. That force of attraction is a Coulombic force, okay? Coulombic force of attraction. Okay, ionic solid. In this type of solid, it consists of ions, and these ions are held together by the strong Coulombic force of attraction. Okay, this Coulombic force of attraction is the very strongest force of attraction. Okay. If the force of attraction is stronger, remember this type of solid usually harder. Okay. Harder. Why this type of solid is harder? Because this here you can have the Coulombic force of attraction, no? And that force of attraction is strong. Okay, if the bond or if the interaction is stronger, then that type of solid will be harder, and also it will be having higher melting point and boiling point. Okay, boiling point and melting point will be higher. Why? Because in this type of ions, we have ions are held together by the strong force. Okay, if the bond is or interaction is stronger, remember that type of solid it will be harder and it will be having higher melting point as well as it will be having higher boiling point. And remember this point. Okay, in solid state, there will be no availability of ions. Okay, and I told in NaCl what are the ions? Na and Cl minus is the ions, but in the solid state these ions are not formed. Okay, as a result, in the solid state the ionic solid will be insulator. Okay, in solid state these act like insulator. Insulator means what? They do not conduct electricity. That is what insulator means. Okay, means bad conductor of electricity and heat. Okay, if they are bad conductor of electricity and heat, they are called by the term insulator. Why they are acting like an insulator? Because in the solid state the ions are not formed. Okay, that is the reason. Now what is the case in the liquid state? In the liquid state or in the molten state. Okay, in the liquid state or in the molten state, there will be availability of ions. So that means if you have the water, if you put NaCl, okay, salt, and what happened, this interaction is there, no, between Na and the Cl, there is an interaction, no, and that interaction can be broken down by the water. Why? Because water have very high dielectric constant, no, that is the reason why the interaction between the cation and NaCl can be broken down easily. Okay, now we have Na and Cl minus. There is a generation of ions, and as a result, in the liquid state, ionic solid conduct current. Okay, in the liquid state, they conduct electricity or heat. Okay, they conduct heat and electricity in the liquid state. Why? Because of availability of ions. Okay, because of availability of ions, they become a good conductor of heat and electricity in the liquid state, but not in the solid state. Okay. The third type of solid is a covalent solid. Okay, in this type of solid, we can see the covalent bond. Okay, covalent bond. Okay, if any solid that have the covalent bond, then it is known as covalent solid. Okay, what is a covalent bond? Covalent bond is obtained by sharing of electron. Okay, sharing of electron between the atoms. Okay, then that type of bond is known as covalent bond. If any solid that have the covalent bond, then it is known as covalent solid. Okay, and tell me whether covalent bond is stronger or weaker. Weak bond, it is a stronger bond, right? It is a stronger bond. The force of attraction is the covalent bond here, and that covalent bond is a stronger bond. If the bond is stronger, then what about its melting point? Melting point and boiling point will be higher. Okay, will be higher. Why? Because bond is stronger. Then whether it is soft and hard, it is hard and brittle. Okay, why it is hard and brittle? Just remember this point. Okay, if the bond is stronger, then melting point, boiling point will be higher, as well as it will become hard and brittle. If the bond is softer, okay, if it is weaker, if the bond is weaker, then melting point, boiling point will be lesser, and the solid will be softer. Okay, that thing you need to remember. Okay, and one more thing we have is that this type of solid, generally they do not conduct current. Okay, do not conduct electricity. They do not conduct electricity, but there is an exception, that is graphite. Okay, graphite is one of the example for the covalent solid only, but this graphite is a good conductor of electricity. Okay, that is an exception. Okay, other example include diamond. Diamond is a covalent solid, but that is not conductor of current. But graphite is the one exceptional example under covalent solid, but that conduct electricity. Okay, and also this graphite is a soft. Okay, here the property changes. Okay, for the graphite, even though it is a covalent solid, the properties of graphite solid is different. Okay, properties of graphite solid are there. It is soft and they conduct electricity. Okay, why it is so? It is because of its structure. Okay, it is because of its structure. First we will see the structure of diamond. In the case of diamond, what we have, what's the structure of the diamond? Here we have tetrahedral structure. The structure is tetrahedral structure. What is the tetrahedral structure? If you have the carbon, and that carbon is connected to 4 carbon. Okay, like this. Okay, carbon is connected to 4 other carbon, and this carbon is also connected to 4 other carbon. Okay, one is connected to this carbon, another like this. Okay, each carbon here in this diamond have 4 bond. Okay, like this. Okay, one is here, 2, 3, 4. Okay, all the carbon have the 4 bonds. Okay, that is what tetrahedral structure of diamond is. Now, what is the hybridization of carbon over here? Carbon hybridization is, what's the hybridization? It is sp3. Right? sp3 is the hybridization of carbon. Okay, remember one thing, I'm just telling the trick. If the number of sigma bond is 4, okay, number of bond, the number of sigma bond, okay, the number of sigma bond is 4. Then what is the hybridization? sp3, okay, 1s and how many p are there? 3. 3 plus 1, 4. Okay, it matches the number of bond, right? If there are 4 bond, it is sp3. If it is 3 bond, then it is sp2. Okay, s is 1. How many p are there? 2. 2 plus 1, 3. Okay, it matches with number of bonds. So if 3 bond means it is sp2 hybridized. If it is 2 bond, what is the hybridization? It is sp. Okay, 1s and 1p. 1 plus 1, 2. It matches with this number 2. Okay, if there are 4 bond, sp3 hybridization, 3 means sp2 and 2 means it is sp hybridized. Okay, now here how many bond we have? 1, 2, 3, 4. So what's the hybridization? sp3. Okay, if it is sp3 hybridization, tetrahedral is the structure. Okay, now what's the bond length here between carbon and carbon? The bond length is 154 picometer. Okay, carbon bond length is 154 picometer. Okay, this is what the structure of the diamond is. Remember, the diamond is the harder, okay, harder, and they do not conduct electricity. But one of the exceptional property is seen in the graphite. Okay, that is mainly because of its structure. Okay, what is the structure of the graphite? The graphite have layered structure. Okay, layered structure. Okay, this is what the structure of graphite look like. Okay, here these ends means it's a carbon. Okay, now this carbon it's connected to how many, it has how many bond? It have 1, 2, 3. Okay, every carbon here have 3 bond. So what is the hybridization of carbon here? It is sp2. Okay, the sp2 is the hybridization of carbon. Okay, now what's the valency of the carbon? Valency of the carbon is 4. Okay, there are 4 valence electron in the carbon, right? Out of 4, 3 are used in making bonds. Okay, the out of 4, the 3 are used to make the covalent bond. But we have 4, no? That means 1 extra electron is there, and that electron will be present in the layer. Okay, this is the layered structure of graphite. 4 out of 3 valence electron, the 3 out of 4 valence electron is used to make the bond, and 1 electron will be present in the layer. Okay, so there will be many electrons available, and that is freely moving, right? And because of that free moving of electron, this graphite is a conductor of electricity. Okay, it is a good conductor of electricity. Why? Because there is a availability of free electron. Okay, and that's why it is a good conductor of electricity. And this is soft. Okay, this is a soft material, and these layers are can slide over one another. Okay, because it is a soft, and they can be slide over one another. Okay, and that's the reason why they are used as dry lubricant. Okay, why they are used as a dry lubricant? Because they are soft and the layer can slide over one another so easily. Okay, that's the reason why they are used as lubricant. Okay, this is about the covalent solid. Okay, covalent solids are having the covalent bond, and these are usually having high melting point and boiling point, but there is an exception that graphite is having lower boiling point and melting point. Okay, and also it is softer. Okay, and the next type of solid we have is the molecular solid. Okay, the fourth type is the molecular solid. Okay, molecular solid means between the molecule there will be a certain type of interaction. Okay, in this here we can see some interaction. Okay, some interaction between molecule. Okay, in this type of solid we can see some interaction between the molecule. For example, if you consider a water. Okay, water structure is this, right? O, H and H. Okay, H2O. If you consider one more molecule of water, okay, O, H and H. Okay, and this is the one molecule of water, this is the another molecule of water. Okay, now oxygen is electronegative, right? It's highly electronegative, and H is the electropositive. So there will be a generation of slightly negative charge over the oxygen and slightly positive charge over the hydrogen, and there will be an interaction between this oxygen and this hydrogen of another molecule. Okay, and this type of interaction is known as hydrogen bonding. Okay, now what you saw, this is the one molecule of water, this is the another molecule of water, and between these two molecules there is an interaction, right? And that is what we can see in the molecular solid. Okay, now depending upon the type of interaction, we have three types. Okay, remember, this interaction can be London force, the London force of attraction. Okay, I'm just telling what are the possible interaction between the molecule. Okay, the London force is one type of interaction between the molecule. Another one is the dipole interaction. Another one you have hydrogen bonding. Okay, hydrogen bonding. Okay, hydrogen bonding between the molecule. These are the three possible interactions between the molecules. Okay, and based on these three different type of interaction, we have three classification under molecular solid. Okay, one is the non-polar solid. The second one is a polar solid, and third one is the hydrogen bonded molecular solid. Okay, these three classifications depend upon the type of interaction between the molecules. Okay, the non-polar solid, polar solid, hydrogen bonded molecular solid. Okay, we will first now see the non-polar solid. Non-polar solid. Non-polar solid means it consists of the atoms like helium and argon. Okay, it consists of atom, helium and argon, or molecules. Okay, it consists of atom or molecules like H2, I2, Br2, like this. Okay, these are the non-polar molecules, right? Because in H2 we have, this is what the structure of H2 look like. Okay, now whether this type of bond is a polar or non-polar, it is a non-polar bond, right? Why it is non-polar? And if you consider I2, I and I, bond is non-polar. Even in the Br2, the bond is non-polar covalent bond. Why it is non-polar? Because what is the electronegative difference? It has got electronegative difference something, and this hydrogen has got electronegative, right? If you take the difference, what you get? Electronegative difference is a 0, right? If the electronegative difference between these two atoms is 0, then it is known as non-polar solid. But if you can see the difference in some cases, for example, in case of HCl, okay, it has got delta plus and it has got certain electronegative value, right? If you difference the electronegative values, whether you get 0, no, you do not get 0, then this type of molecule will be a polar molecule. Okay, for example, even in the water is a polar, because this bond here it is delta plus and here it is delta minus. If you if you take the difference between the electronegative values of H and O, it is not 0. If it is not 0, then it is not a if it is not a non-polar, that means it is a polar. Okay, but here in case of H2, I2, Br2, the electronegative difference between the two atoms is 0, so it is non-polar molecules. Okay, and here you can see, we can see London force. Okay, London force, as I already mentioned, there are three different possible interaction: London force, dipole-dipole interaction, hydrogen bonding. No, so if you can see the London force, Then in the case of nonpolar solid, you can say London force. Okay, that means if you have I2 and I2 like this, I2, there will be an interaction. No, that interaction is a London force. Okay, this is the weak force. Okay, this is a weak force of attraction between the molecules. Okay, if it is a weak force of attraction, whether this type of solid is harder or softer, it is softer. Okay, if the force of attraction is weaker, then it is a softer. Okay, then what about this melting point and boiling point? Boiling point and melting point is low. Okay, melting point and boiling point is lower. Okay, and remember, they will be present in the form of liquid or gaseous at room temperature. Okay, at room temperature they will be present in the form of liquid or gaseous. Why? Because they are having very low boiling point and melting point. As a result, they will be present in the form of liquid or gaseous, not in the solid form in the room temperature, but below room temperature they will be present in the solid form. Okay, next one we have is the polar solids. Okay, in this type of solid we can see dipole interaction. Okay, we can see dipole interaction. Okay, polar solid, in this type of solid we can see dipole interactions. Okay, examples include the solid sulfur dioxide, solid ammonia. These are the examples for the polar solids. Okay, these are slightly harder. Okay, slightly harder when you compare to the non-polar solid. Okay, slightly harder than non-polar solid. Okay, polar solid will be softer only, but they will be slightly harder when you compare to non-polar solid. Okay, the third one we have is the hydrogen bonded. The hydrogen bonded molecular solid. Okay, this is the third and the last type under the molecular solid. And here what you can see hydrogen bonding. Okay, you can see hydrogen bonding between the molecule. I previously explained in case of water, right? Here, okay, here what you can see the hydrogen bonding. No, if you can see hydrogen bonding, then that is known as hydrogen bonded molecular solid. Okay, what is hydrogen bonding means? Hydrogen bonding means it is the bond between hydrogen and most electronegative atom. Okay, most electronegative atom may be oxygen, nitrogen and fluorine. Okay, if you can see the bond between hydrogen with oxygen or hydrogen with the nitrogen or hydrogen with the fluorine, then that bond is known as hydrogen bonding. Okay, and these are the non-conductor of electricity. Okay, and they are usually volatile. Okay, they are usually volatile or soft solid. Soft solid means they are volatile. Okay, soft means it is the soft solid means they are hardly solid at room temperature. Okay, in room temperature they are hardly solid. Okay, they will be usually present in the form of liquid. Okay, soft solid under room temperature and pressure. Okay, these are about the properties of hydrogen bonded molecular solid. Okay, in the case of hydrogen bonded molecular solid, we can see hydrogen bonding. In the case of polar solid, we can see dipole-dipole interaction, and in the case of non-polar solid, what we can see the London force between the molecule. Okay, this is depending upon the force of attraction between the molecule. We have three different classification under the molecular solid. Okay, if there is any doubt in this video, please do ask me in the comment section. Okay, if you liked this video, please subscribe to my channel, and please share this video. Okay, thank you.